Hello, everybody. Welcome to OpenCV Weekly Webinar. I am Dr. Satya Malik, and today we have with us who has been with us for a long time. He has been on the show several times. Lu is the CEO of Cortic Technology, and their team, Cortic Tigers, actually won the grand prize in the OpenCV AI Competition 2021 with their very cute robot called Charlie 2.0. And today, Ye will share some valuable insights into building AI applications more efficiently. But first, with me, as always, is Phil Nelson, who is the Director of Content and Creative at OpenCV. Phil.
Good morning, everybody. Once again, it is I, the co-host with the co-most, back to being a co-host, the second banana who is second to none, your plus one and only. You may notice we are not in the beautiful OpenCV Weekly studio this week due to some issues. Again, we think the cat might have got into some stuff. It might be mad because it doesn't have a name yet. It's tough to tell. I don't speak cat. However, we've got a couple of things I'm going to remind you about at the top of the show here. First of all, we do a giveaway to you in the audience in the Zoom chat. If you're not in the Zoom chat, you can get there by going to opencv.live. We'll be doing a giveaway at the end of the presentation based on a trivia question, which you'll find the answer to in the presentation, so stick around and pay attention. We'll also be taking Q&A from you in the audience. Please use the little Zoom Q&A button at the bottom of your screen, or ask your question in the chat system of wherever you're watching us, YouTube, Twitch, LinkedIn, Twitter, Facebook, whatever, man. It's all good. Also, we've got a heaping helping of OpenCV related news this morning to start off the show. I'm going to share my screen real quick here and show you all a few really, really cool things. Starting off with OpenCV AI Scavenger Hunt. A lot of you have been playing. This is week 3 of the Scavenger Hunt. If you haven't played or you haven't even heard of it yet, the way this works is each Monday in October, this is the 3rd week, we give you 2 AI models from OpenVINO notebooks. We give you 2 clues and 1 AI generated image. Your goal is to use the clues and the notebooks to guess the prompt used to generate this AI image. This is week 3's image, you can see there. Week 2 is down here. The answer to this one was longicorn, which is a kind of beetle, but the AI interpreted that, as like a unicorn kind of thing, which was really interesting. This was our first one that I believe Christian, no, it wasn't Christian, it was maybe Pierre. One of the submitters here actually guessed it perfectly, which shocked me.
Perfect.
Yeah, to the letter. Longicorn, comma, space, modern was the exact prompt here. Yeah. The first one was much longer. This one is a Halloween carved pumpkin with a cute Pembroke Welsh corgi Unreal Engine render. Congratulations to Dhruv, who won the weekly drawing. If you answer correctly, you'll be entered in a $125 weekly drawing, as well as a $500 drawing at the end of the contest. Congratulations to Christian S., who won the $125 weekly prize in week 2. You can play. It's free. Go to opencv.org/hunt. You've still got 2 weeks to participate and be entered for $125 for the next 2 weeks and $500 at the end of the contest. The folks that have answered every week and gotten it correctly will be entered for a $3,000 grand prize. So good luck to all of you that have still done that. I believe there are 3 or 4 people still left in the running, so it's exciting.
So the grand prize, aren't we selecting? I thought we were selecting it based on who has the closest prompt, and if there is a tie, we will do a.
It will. So basically, you get you kind of get points per week. If you've answered correctly, you're at the top of the top of the pile, as it were. It may just be that only one person answers all 4 weeks, and they just win. If 3 people get it, we'll split it 3 ways. Yes, those are the rules. Thanks for reminding me of that, Satya. Moving on, we've also got OpenCV AI Competition 2022. We have selected the 25 teams for the spatial AI track that are tasked with improving the depth estimation of the Oak D Pro, which is the latest and greatest OpenCV AI kit. In fact, I have one here in the studio. I'll grab it. I got this sweet baby here. You can see in the chat there. The biggest thing here, of course, is that it now has a built-in laser. So, avoid looking directly into the laser with your remaining.
The dot projector, yeah.
Yeah.
It also has a floodlight. So it has a
Right,
dot
an
projector. It also has,
infrared flood, right?
yeah.
Yeah. Very similar to, if you followed my career or you recognize me from stuff, very similar to the structure sensor in the way that it works. So yes, congratulations to all of those teams. I was going to read your names, but I forgot to make a list of your names that I can read out loud. So sorry about that. But congratulations and best of luck. You all have until October 18, 2022 to crank out some incredible improvements to depth estimation on OpenCV AI Kit D Pro. Also,
yeah, and the core OpenCV track is still open. You have until the end of this month to submit a proposal, but it is completely open, right? There is no that deadline is also kind of weak. You should just work on your project and submit. A one-pager proposal is sufficient because we are going to judge it based on the finals, whatever you submit in the final. The proposal is for us to know what you're working on and if we can suggest something useful. But I would suggest that go and dive into this. If you miss the spatial AI part, you should just go and dive into this track of the competition.
yeah.
And it is pretty open-ended. You can pretty much choose any problem that you wish to solve using software, hardware, anything, right? Build something interesting using computer vision.
Yeah, we had a bunch of people, a few emails in our inbox. They were sort of confused. That's competition@opencv.org. They were sort of confused, expecting that we were going to choose teams for a phase 2 of the core OpenCV track. That's not the case for this competition. Basically, you just have to send us a PDF telling us what you're working on, and we'll tell you, great, go ahead, make it awesome. Unless, of course, it's something we find physically repellent, in which case we'll say, please don't do that. But I mean, it's open source. We can't really stop you. But moving on to OpenCV face recognition. Satya, you'd like to talk a little bit about this?
Yeah, so OpenCV face recognition. We when we started OpenCV, one of the main attractions where the library really took off was this implementation of face detection, not recognition, but detection. It was an algorithm by Viola and Jones. So that was that was how the whole thing started. But gradually we saw that face recognition has advanced so much that it is almost impossible to have the state of the art in this domain without having a dedicated large team working on it day in and day out. And so what we decided is that we partnered with this company called 7sense. They already had a model that was in the top 10 in NIST, which is a face recognition grand challenge. And so we decided we'll partner with these guys. I did some of the tests myself. I actually put them on the spot at Embedded Vision Summit last time. And because they were saying that they had made good progress, and so using my ID, they enrolled me using my face and then verified it using my driver's license. And you can see, right? It's not, even for humans, it's difficult to match from a real picture and driver's license. There's a lot of things. So
yeah, every bouncer in the world would agree with that one. every doorman, every bouncer, yeah.
Right. So I haven't had a long career in that, but yes, I guess they will.
You've never used a fake ID to get into a bar when you were like 19 years old?
Well, I started drinking anyways.
Fine, just make me look like an alky, Jesus.
I grew up in India. My dad was in the military. I don't need an ID to drink at the age of 10.
Good point.
Anyways, can you cut that out, please?
Not now, I can't.
Okay. So 7sense, we have partnered with OpenCV, 7sense to bring a face recognition, and if you sign up using that page, we will give free credits to 100 people, which that's great. This is one of the things that I do for our users. I squeeze these companies who are partners with us to give free stuff to our users.
That's right.
But I think this is going to be really good. It would be an API. It will also have a pip version which you can install. But it is a commercial version of, because face recognition, it requires a lot of investment, etc. So it is a commercial version. There will be a free version that people can try, but with volume, we will need it will be a premium kind of model. So yeah, please sign up, and we'll notify you when it's ready. Early November is what the current target is, and we'll be rolling it out. The people who registered earlier will get first access, and then gradually we'll be rolling out.
Excellent. All right, that's all for the myriad OpenCV updates this morning. I think I'm going to stop sharing my screen here, and we will turn it over to our esteemed guest, Lu of Cortic Technology. Take it away.
Thank you, Phil. Let me share the screen. So hi guys. My name's and the topic for today is to talk about rapid AI application development. But before I do that, I want to do a little recap about what the OpenCV competition meant for us last year. So basically, we went into the competition with the mission to democratize AI for everyone. So we tried to do that with Singapore Computer and Legos. And the competition actually provided a whole bunch of values for us. And here I'm listing the top 3 values. So by participating in this competition, it was a great opportunity for us to get to know the AI landscape. I believe last time there were more than 1,200 entries into phase 1.
1,400.
1,400.
Yeah.
1,400 entries. So they're from all over the world. So it was a good opportunity to see what everybody's working on and to talk to a lot of different developers. So the result of that is that potentially there are lots of partnership opportunities. So, and all of the developers I talked to, they're all very friendly and they're all eager to work with us. So we were really happy to see that. And one of the most important things, or one of the most important takeaways from the OpenCV AI competition is that it gave us a chance to figure out what the industry pain points are. So by talking to the developers, we get to find out what their daily challenges are for building AI applications. So this is what stems for the presentation today. So we're trying to figure out what we can do to make building AI applications quickly and more efficiently. So, well, there is an astonishing statistic floating on the web recently. So it was actually from a Gartner report this year in January. It says that 85% of all AI projects ended up failing. This is an enormous number. So if we somehow think that AI is going to have a tremendous impact in the world, we need to substantially reduce this number. So if we ask ourselves, why do all those AI projects fail? Well, for us, we did some investigation and talked to a bunch of people, and we came up with the following reasons. First, in order for AI to succeed, you have to have a very well curated data set. And then you have to be able to correct your labels. You have to be able to do reliable tests to see if your trained model is actually improving the accuracy and so on. So this was kind of difficult before, but I'm sure for all the attendees to this OpenCV webinar, we're probably familiar with this tool called RoboFlow. So RoboFlow, I found, is an awesome tool for this purpose. You can submit your data set, you can provide labels, you can train your models, and you can evaluate the accuracy. So if you haven't already, I strongly recommend that you check out RoboFlow if you are having an issue with data.
You can try out RoboFlow by going to roboflow.com/OpenCV.
Okay, so aside from data management, in order to have a good quality AI project built, you have to have skilled AI engineers. But skilled AI engineers are very difficult to find. I think the root of the problem is that it's hard to get started with learning AI. For example, if you're a high school kid, it's next to impossible for you to learn the insights and the ins and outs of AI, because if you go on the web and you try to find a tutorial, they talk about college level math to start. So this is, most people get turned away from that because they find it too difficult. There's too much time investment. And even if you get past that, you try to set up some of the open source projects, it's hard. You have to install a lot of dependencies and so on. It's just too much friction. Lots of people are turned away by that. So again, besides this problem, AI projects themselves are very architecturally complex because if you have a non-trivial AI project, it usually means that you have to use a mix of different hardware environments or different operating systems, and they need to work together somehow. So to have a successful project, it needs to be architected very, very well. And then experimenting with different AI technology tends to be difficult. Well, this actually has to do with what I just talked about, because just providing education for people to providing an opportunity for people to explore is difficult, because setting up the even the open source project can be non-trivial sometimes. Also, one of the most important things that we found in developing our own AI project is that the traditional waterfall model of software development doesn't really work, because you can't keep your head down and develop your project for a year before you show it to your customers, and then try to evaluate whether your AI project actually solves their problem. You can't do that. You have to do it iteratively. So it means that it needs to be, you need to come up with a really fast prototype and show it to your customers, get their feedback, and then iterate. So also, if you're a data scientist, and your data is partitioned all over different servers, it can be very difficult for you to do data visualization. So if you're a data scientist and you can't visualize the data, it can be a problem for you. So, and most importantly, what we found is that after you deploy your project to your customers, your work is not done. You actually need to manage your deployment. You have to provide monitoring for the AI project, and in order for to collect meaningful data. So what can we do to address these problems? Well, I talked about RoboFlow, but data management, but hopefully we're going to be able to tackle the other points in my talk here. So what we think the solution should be is that it needs to be a cloud management platform for AI, edge AI devices. Right now, because of that last problem for deployment management and monitoring, lots of people turn to cloud-based AI solutions, but it doesn't really work for real-time application, because cloud-based AI introduces a lot of latency. So if you're faced with that problem, you probably want to move your AI inference to the edge. So I think a good compromise for us is to have a cloud management platform, but it needs to manage all the AI edge devices. Also, in order for AI to be decoupled from the actual business logic, we are proposing to use a standardized protocol for microservice-based AI deployment. And going with that, we need a very easy API for service instantiation and invocation. Also, we need an edge computing platform to support and host locally deployed microservices. And last but not least, of course, we need an intuitive UI library to support easy data visualization. Hopefully, these will address some of the pain points that I talked about previously. So here I'm gonna attempt a few live demos. Hopefully this will go well for us, just like what happened last
Yay.
time.
I love live demos, my favorite thing.
All right, so can you see my browser window?
Sure
Yeah.
can.
Okay, great. So this is the cloud management platform that I'm talking about. So in here, you can see that I've already set up a bunch of different devices using different operating systems, different hardware. Some of them are online, some of them are not available right now. And you can on our platform, you can deploy arbitrary apps to this group of hardware. They will function as a single unit to try to offer the compute capability that you need for your app. And also there's a console. It will display everything that happens or any errors that you might see. So I have a few apps that have already been uploaded. You can click the upload button to upload your app. And then from the app, you can deploy it to any hub you want. And I've just because of time, I've already deployed some of the apps already. So let me go back to my slide, and then I promised something about making AI application development easier. Well, let's do a really small hello world app, but it's an AI application, so it's not going to be the three-line print hello world. It's going to be slightly more involved. So let me show you maybe the code very quickly. So the main program for this hello world is slightly more involved. It's 50 something lines, but most of that stuff is just to set up the data source, the camera, and to where you want to display the image and so on. But the actual substance is in this process loop. Basically, you can see that is acquiring an image from a camera source, and then it's calling this face mesh destination task. This is actually a microservice hosted on this platform. So what I mean by easy service invocation is that all the service invocations should look like function calls, local function calls. And that's what we're trying to do. And you can assign the input image into the face mesh task, and you can just send it out. And if you're a seasoned AI engineer, you probably noticed that I'm not doing anything special to handle any asynchronous events, because model inference doesn't happen instantly. So usually people do it asynchronously by defining callbacks or listeners and stuff. I'm not doing any of that. So the reason why we don't have to is because we're trying to make asynchronous programming just as easy as synchronous programming. So you can just write out your program as if they're sequential, and we'll handle all this asynchronous stuff for you on the back end. So without further ado, let me show you how this program runs. So this is the fish mesh program I already deployed. It's actually using the OP camera. So if I hit right here.
So this app, the app the code that you just showed,
Yep.
is it is it the same code that was uploaded?
Yeah, that's that same code, and this is the code that's currently running. So you can see that it's actually sending all the video and the data, everything through
It's a very nice UI you all have built here. I'd like to know a little bit more about how this all works.
Sure. Yeah, we can talk offline if you like.
Yeah.
You can see everything running here, and because we're using an OP camera, it knows the depth. So if I move further away, you can see that my distance is further away. If I move closer, it's closer. But
so that's the thing on the left-hand side.
That's right. That's the distance slider on the left-hand side. So but you notice that because it's streaming over the web, it's a little choppy, right?
Yeah.
So, but there's no reason why I can't look at the locally running program, because it's running on my Mac for the demo purpose, right?
So just so we understand,
Yep.
so you uploaded this code, and that got deployed to the OAK-D. Where did it get deployed to? It got
Okay.
deployed to your local machine?
That is a great point. So I'm going to answer that in the next demo. So the short answer is that it doesn't really matter, but I'm going to make it clear in the next demo.
Okay.
So in here, you can see that we have an application, a Mac application running locally. Basically, it offers the same kind of view as the web-based application. And what it can do is that I can switch over to the app view. You can see that, hey, this is the same app running. You can see it running locally as well as on the web. And you can see that this is actually very smooth running locally. I don't know if you can tell the difference over Zoom. And
yeah, it's a little bit smoother locally. We can tell the difference, yeah.
Oh, perfect. There's actually a few interesting things that I want to point out. One of the things here is that if you look at the face mesh, it's actually being baked into the image over here. So before we send the image out to the web and to any of the receiving sources, we're baking in that drawing. But the HUD or the little piece of UI on the left-hand side, this is not baked in. This is actually being rendered on the client. So if you're using a web client, this is being rendered on your browser. So I'm just trying to illustrate the flexibility in which you can compose your results here. And also, because this is a hello world application, if you look at the console, you go in here, wow, you see the hello world text. And this is from the this is from the console output. And I just want to point out, because this is the standard OpenCV join routine that you can see. I'm drawing on the image here, and this is the measurement bar. This is the client side drawing. The special thing about this program is that it allows all of the coherent components to live in the same project. You don't have to distribute it over different projects and manage them differently. Everything stays in one place, and everything handles the same data input and output. So, okay, let me stop this for now. Oops. Let me stop this and take a look at that. And it's also stopped locally as well. So, but sometimes you may have to ask, what if I'm a student? I just started out and I don't have any specialized AI accelerator devices like the OP. Well, would your Hello World app still run? Well, it should, because Hello World is a program that should run everywhere, right? So instead, what we need to do, what we can do to simulate this is to take down the OP host here, and we're going to bring up a webcam host, because all of the computers nowadays got webcams built in. So this is active now. And then if you don't have any AI inferencing, specialized inferencing devices or accelerators, well, everybody's got a mobile phone, right? So let me start up our device running on the mobile phone. So you can see that my iPhone just went active because it started my device manager. So again, if I go into the app and hit run, remember I have done no code modification. Everything stayed the same. And I should be able to get that image somehow.
Live demo.
Oh,
exciting.
Restart.
It's funny.
Let me restart this.
Hey, software.
Working here. Yeah, because I didn't hit stream to cloud. So anyway, anyway, you see the same application just runs with a completely different hardware configuration with no modification at all. So
So this
So
is
to
running
answer,
on the phone?
yeah, this is running on the
Okay.
phone, and the result is actually being typed over here, just as if you're using a local device.
Right. So just so I know,
So in order to
this
see what's actually running here, so you can go to devices, and you can see that you can see the task executing here, and you can see the load because the iPhone is pretty fast. So
yeah.
this face mesh thing is very simple, and it's only doing about 12% of load. So if I stop it, you can see the load dropping. Yeah, it's going to drop to about 4%.
Neat.
Yeah. So anyway, so our design goal is so that you can deploy your app anywhere without knowing the infrastructure behind it, as long as you have the required services hosted on your platform. It should just run exactly the same way as it runs anywhere else. So let's continue on. So with all of the AI development, a crucial step for a successful AI project will involve some kind of AI model tuning. So there is one open source project that I can't recommend enough. It's called the Apache TVM project. So we run all our models through this tuner to make it more efficient if we know the target platform. So what this Apache project does is that it's a model compiler and a optimizer. So it compiles the models in TensorFlow, PyTorch, or Onyx formats into its own intermediate representation, and then it does a bunch of optimization, and then it outputs it into machine language code that you can use in your Python program or Rust program. So just to give you an idea.
One quick question. Is it so I've never used Apache TVM. Is it very close to what OpenVINO and TensorRT these are trying to accomplish? Is it a competing sort of technology?
Yes, it's very similar, except that
Yep.
it supports many target platforms. So this
Okay.
supports desktop GPUs, the AI accelerators, as well as single board computers, MCUs, everything. So if you know your target platform and you know that if it's not supported by one of the TensorRT or whatever, you can use this tool to make your model more efficient. And
Nice.
here's a little comparison for the type of performance gain you can expect. So if you tune this model on the desktop computer, you can see that you can expect anywhere from 10 to 700% performance gain. And then if you're working on embedded devices, you can get a similar level of speed up as well. So this tool is great, but you need to constantly monitor how your when your model is turning, right? Tuning. So what can you do? So there is a big initiative at Cortic is that we need to eat our own dog food. So instead of monitoring everything manually here, we actually wrote a little program to do the monitoring for us on our platform. So I'd love to show that to you. So if I go back here, and I go to apps, and there is this model tuner program. So this goes to the monitoring of the AI project stuff that I talked about before. So in here, stretch it out a little bit. So you can see that it's obviously a distributed workflow because we can manage many different devices, and each device can manage different nodes. And then there's a whole bunch of models in here that this program managed. So if I choose to tune it at some other excuse me in some other node, I can do that. But I already have something running here, so so this will allow me to monitor how the model is tuning remotely and in real time. It shows me all the log files, and I can see what's being tuned and what the performance gain is and everything. And then I can I can stop the model training process anytime I want, and then in the future we'll be able to download this model to service for something that we want to post on our platform. And if I stop this program, this doesn't mean that I'm stopping the tuning process. I'm actually just stopping the monitoring. So if I start it up again, you're going to see it the way it was before, and it's still tuning. Yeah. So great. So now that I've showed a toy project and a internal tool, maybe some of you might ask, well, this sounds great in theory, but how does it work in the real world? Well, this is something I want to show as well, because AI is supposed to help people. So the first group of people that we think that AI can help is people that suffer from Parkinson's disease. So right now, if you have Parkinson's disease, and you go and visit your neurologist, the doctor will have to spend a lot of time accessing the progression of your disease. Basically, it will tell you to do, excuse me, he'll tell you to do a whole bunch of small tasks, and then he'll evaluate from looking at how you're performing those tasks. But what if we can automate that and free up the doctor's time to do additional research, or maybe he can just spend time with the patient's family to talk about alternative treatment plans and so on. So this is exactly what we're building here, and we're working with the Pacific Parkinson's Disease Research Center at the University of British Columbia for this pilot project. So let me show you what this project looks like running in real time. So, I need to mention that the leader of this project is Dr. Martin McCallum from the University of British Columbia. So if I run it, so this is actually, stretch it out a little bit. This is not a login screen, but it's actually a screen to match you with the patient record. So if I touch me myself, and then I'll just use 1, 2, 3, 4, 5 as my patient ID. I can log in, and then you can self-serve. You can perform a number of those tasks yourself instead of having your doctor trying to tell you what to do. So let me show you this task. A finger tapping task. It will explain what you need to do. And if I continue, it will tell you, hey, I don't see your right hand right now. Maybe you need to raise your right hand. So I reach my right hand, and it goes into here. And then it'll wait for me until I tap my finger. When I tap my finger, it will produce a plot.
Wow.
And it will compute all the required numbers that the doctors want to see. And then, I need to switch my left hand now. So there we go. Switch my left hand. Let me do the same.
This is very nice, very nice UX work here.
Yeah,
thank you.
It's very smooth.
About the UX, this is actually the thing about easy UI construction. Building this UI is actually trivial on our platform. So I love to show you more, but I don't think I'll have time to do that. But another thing that we can do is to track eye movements. So so the doctor is looking for something called OKN, which stands for optokinetic nystagmus. So basically, we need to the patient needs to watch a bunch of strips being animated, and then in different directions, of course. And then go up and down. Anyway, I think you get the idea. But in the background, because we can't show any of the tracking statistics on screen because we don't want to distract the patients. But
yeah,
under the hood, what we're doing is that we're actually doing this. So this is what the kind of stats that we're actually tracking. We're doing the distance. We're actually using a OP camera for that. We're tracking the distance between your head and the screen, and we're tracking your gaze. We're tracking your facial movements. We're actually computing your head motion and everything else, and we're computing the displacement of your iris and the number of blinks. And in here, for let me start this. In here, so if you look at the displacement of the iris over time, you can see that it actually, for normal people, it needs to look something like this. It needs to have this sawtooth pattern. But for Parkinson's disease patient, so the control group, this is still sawtooth pattern, but for people with Parkinson's disease, and depending on how advanced the disease is, you can see that the sawtooth pattern goes away. So this is what the doctor looks at to decide how advanced your Parkinson's disease is. So in here, we're also working, but it's an ongoing project, and we're also working on different modules. One of the other modules that we were thinking of doing is probably a gait tracking module to monitor how people are walking and whether they will suffer from falls or whether they're balanced correctly. So for this project, this is another cool piece of hardware we're thinking of supporting. This is the Microsoft Azure Connect camera that we're going to be supporting on our platform as well. So this again is very similar to the OP. The reason why we're not using the OP for this is because we're actually waiting for the next version of OP with the much better AI accelerator. But in the meantime, we're going to use this Microsoft camera. So it's very similar to the OP in that it's a depth sensing camera as well, but it offers slightly more range. So for the purpose of gait, I think it suits this application perfectly. Anyway, so this is pretty much all I want to show today, and hopefully I'm able to give you a little glimpse of what AI application development should be like. And it shouldn't have to be frustrating. It shouldn't have to be time-consuming. It should be fun for us. So if you check out our website, we have a model that says make, learn, and have fun. So basically, that's what we're trying to do. We need to make something, learn something every day, and most of all, we need to have fun. So if you're interested in this project, you want some news updates, or you want to give us suggestions or whatever, feel free to follow us on Twitter or LinkedIn. And before we take any questions, hopefully, I'm just going to do this because it's almost Halloween.
Yes.
And I want to show one of the projects that we've done using the software that we built for the previous OpenCV competition. This is a computer vision driven jack-o'-lantern. So it uses OP light, and the jack-o'-lantern will follow you around, and if it sees a person, it will try to play some creepy speech, and in the meantime, you'll play some music and stuff. If you want to know, if you want to find out how to build it, please check out our blog post. It contains a very detailed building instruction on how you can use Lego motors to drive your jack-o'-lantern, and all the source code, of course, is open source. So that's it. And yeah, if you have any questions or.
Well, first I would like to say that I love how you're bold and you always come up with live demos. That's really great. It speaks a lot about how confident you are about the solutions that you're building. So that's really great. I also really am surprised by how good the UI is, and it's a very nicely done app. Now, one question I have is, let's say in the Parkinson's example you said, right, if you did not have an OAK-D, let's say you had a phone instead, right? Yep. Could you do the same thing? Maybe there is some level of preparation you need to do, but let's say you have installed things on the user's phone. Could they just do it with the phone instead of needing to have an OAK-D? OAK-D would obviously be better results, but could they just do it with the phone?
Yeah, for the finger tapping, you can definitely do it with the phone. And the only reason that we need the OAK-D is for depth in those cases.
Yeah.
it will give us it will help us do gaze mapping on the screen for the eye tracking task. But for phenotyping, definitely you can change it to any kind of hardware that can host the type of services that we need.
Yeah, and the optimization, it is done by the Apache TVM you mentioned. Like, for example, when you do iPhone development, AI for iPhones, then you have to be very careful because, there are these 16-bit compute units that if you use them, they are blazingly fast, right? So, and it's different, right? iPhone 12 has a different number of them. iPhone 13 has different, and iPhone 14. So how does so all that comes for free using Apache TVM, or do you need to tweak?
The iPhone is actually a special case because for the iPhone, you don't really have to do that. iPhone offers a really great SDK called 4ML. So all you have to do is convert that model for 4ML, and all the optimization will be done. And then you can use 4ML just the same way as you do for anything else. You can run inference very efficiently on iPhone.
Yeah. Okay. Yeah. So that part I know.
Yeah.
Great.
Yeah. And I forgot to mention that we're trying to hit alpha at the beginning of the year. Oh, sorry, at the end of the year, and hopefully we'll have a public beta by the first half of next year. So if you're interested in participating in the beta, please follow us on LinkedIn or Twitter.
So my question is are you building the platform, or are you building specific solutions for people?
No, we're not building solutions per se. We're building a platform. But in order for that platform to be useful, we have to do a number of pilot projects. This is what we're doing with the University of British Columbia to make sure that we address all the needs that developers require.
Yeah, that's great.
Yeah,
that's great.
Yeah, you don't want to build like a cargo cult thing that you're building a simulacrum of an airplane out of sticks and twigs and hoping that it brings great wealth upon your tribe or whatever. We don't want that, and you get that a lot, and especially I think in AI and computer vision, you do see a lot of these projects that, for lack of a better term, they're just simply not dog fooding it, and so the UX is bad. And that's not the case here. It's really impressive what you all have pulled off there. We've got a bunch of questions from folks about how this works and the UI and whatnot. But first, I think we should do our giveaway. We're at 9:50 here. So, folks, if you are just joining us for the first time, or if you need a reminder, one of the things we do every single week here on OpenCV Weekly is give away something to you in the audience for free. This week, we'll be giving away the OpenCV course of your choosing. You can go to opencv.org/courses to see what we have available. There's Deep Learning with PyTorch. It's a great way to level up your understanding of computer vision and artificial intelligence by learning from the experts at OpenCV, thanks to our friends at Big Vision, for example. So you're going to answer a question that I have come up with based on the slides from Ye's presentation here in the Zoom chat. If you are not in the Zoom chat, you can get there by going to opencv.live. Quick. So get ready to answer in the Zoom chat. The first person to answer correctly will win the OpenCV course of their choosing. If you have won in the last 2 months, please do not answer and give someone else a chance to win. Earlier in the presentation, Ye talked about how a huge percentage of AI projects fail. What percentage? Richard already got it.
Wow.
You have to,
That's why I've been doing 2 questions. I should have done 2 questions again. I gotta throw him some curveballs. Yowza. All right. Congratulations, Richard. Richard Chung, show us. Send one email to phil@opencv.org with the course of your choosing, and we'll make sure that you get access to that for free. Congratulations. Way to get inside my head there. So I'm also going to, while we're here, before we do a couple of questions, I promised I would read out the names of the teams who have been selected in the Spatial AI track of OpenCV AI Competition 2022. We chose 25 teams. Those teams are Weed Seeker Bot, Sudo Voodoo, 3Vision, 425 Tiangong, Control Engineers, Pioneer, Depth Space, Eyes for Humanity, Alba, RoboEyes, Eagle Eye, Depth Refiners, Spider CV, spooky, Vision Pi, Mysterios, it's a good one, Spirit, Kawawa Bear, Pixel Match, Ratatouille, Rockford Tech, Dab, Crimson Flippers, 996 Brothers, 8 Bytes, that's ATEBITES, cute, and Smells Like ML. Congratulations to all of these teams. You all already have your promo codes for your free OakD Pro and free shipping for that. So we look forward to seeing your progress as time goes on. You know, some of these teams probably might want to hold some of their methods to themselves to give themselves a better chance to win, but we encourage you to post about what you're working on using the Oak22 hashtag. Now, we have got a ton of questions. We're not going to be able to get to all of them, but I'm going to ask a few here. Richard, our trivia winner, would like to know how much, if any, of this framework y'all are building is going to be open source?
Actually, we're thinking of open sourcing some of the edge computing components. Actually, the project that we've done for the OpenCV competition, that was the predecessor to this project. So a lot of the technologies or innovations that we came up with for this project actually stem from that project, and that project is fully open source.
Yeah, and so you're saying maybe it's not as well polished as what you're working on now, but pretty much all the things that exist here do exist in some form in that open source project that from the competition.
Exactly. Yes.
Great. Yeah, and you can find that on GitHub. Ken would like to know. So you mentioned the Microsoft Azure Connect camera. I've heard about this a bit from our friends at Microsoft, but I haven't actually gotten to see one. How do you find the Azure Connect compares to OakD?
Actually, we just got our hands on the camera. We haven't had time to play with it yet, but from the limited number of tests that we've seen, it's awesome. The depth perception is very awesome.
Cool. Yeah, we'll look forward to, you know, if you want to find out more, follow Cortic on Twitter or LinkedIn. I'm sure they'll be posting about it once they actually open the box and get to try it out. Ken would also like to know, what frame rate was that face mesh tracking demo running at from earlier?
Yeah, it's actually running at 30 frames per second. But if you look at it on the web app can only render 15 frames a second. So that's why you saw a little bit of choppiness. But the inference is actually 30.
Yeah. So the funny part in a lot of these applications is that the display part is dominant, and the inference part is actually usually takes much less time, and then you have to display the results, and that actually ends up slowing down the system in a lot of these demos. But inferences are fast.
That's funny. There's a lot of things in artificial intelligence, I think, as an industry and as a workflow that are maybe not, they're sort of backwards from how you would expect if you're if you're unfamiliar with it, and I think that's definitely one of them. Let's see here. Partho would like to know, so I think you already answered this, that you're hoping to have an alpha later this year and a public beta in the first quarter of next year, and so you'll have. Do you have any idea of how that'll work? Like, will it be something you sign up for and get access to? You know, will they be able to? Will there be like a private Git repository or something like that?
Yeah, so what we're thinking is that for the public beta, it's going to be, we're going to have a site set up so that you can set up an account. And then once you have the account, you can just get in and there will be documentations for you to use to try to write your own programs on the platform. And what we're thinking also is that it's going to be very affordable monthly subscription rate for students. So it's not going to cost more than a cup of coffee for you per month.
Okay, that's cool. Yeah, I already have a bunch of ideas for this. I mean, if somebody wants to build this, here's a freebie for you. Video game cartridge scanner that automatically looks up the stuff on eBay and also grabs the cover art and all that good stuff. If you build that for me, I will absolutely buy it.
It's like a library for cartridges?
Exactly.
Okay.
Exactly. And because, they spike in value, and some of them, like, I have a big enough collection that it's hard to keep track of some of the things that I have.
Right.
Tom would like to know, would you be willing to share your slides from the presentation? We'll link them in the YouTube description if so. Will you share your slides, yeah?
Yeah, absolutely. I'll send it to
Awesome.
you after the presentation.
Awesome. And Raj would like to know, what web framework is this built in? Is your front end and back end built in?
Yeah, actually, all of our technology is built with Flutter. It's not any other web framework. So this will allow us to support all of the platforms at once: desktop, mobile, whatnot.
Yeah, I've never used it. I've heard of this, but I've never used it.
Yeah, but the programming language you use to develop your app is actually Python.
Right.
Yeah. So
it's interesting. So if you were going to compare this with some of the other, there's a ton of Python UI libraries out there, like tkinter and blah blah blah. Do you how does this compare to that? Why'd you choose Flutter? Yeah,
so the actual UI that you saw, they're actually not made with Flutter. So you program those in Python. It's your app. Your app is Python based. So what we've done is to construct a bunch of display servers and allow you to write Python code that will be displayed with a Flutter display server.
Interesting. Well, it definitely looks.
So
great.
it's basically streaming the entire UI. Is that right?
It's not streaming the UI per se. It's streaming the instructions for dealing with the UI.
Okay. Got it.
So it's just kind of, yeah, it's very interesting. Yeah. And so what about the back end here? Like, are you using any other frameworks? Like, so somebody suggested it might be Django.
No, nothing special.
No? Okay.
Everything else is done in Flutter.
Cool. Yeah. Gosh, I think that's about it. Thanks so much, Ye, for joining us again. Satya, you want to take us home?
Yeah, so thank you so much, Ye. This was, as always, you always impress us with your presentations, and this was not an exception. I really learned a lot from your presentation, and I'm sure our audience also enjoyed it a lot. Thanks for coming on the show, and I'm pretty sure that you'll come to the show again in the future. This is amazing. Thanks.
Yeah, thank you for having us here.
We'll definitely have to book you for your open beta. Go ahead, Satya.
Well, I was going to thank you next.
Shot myself in the foot there.
Well, thanks for putting this together. I know it's a lot of hard work, but you always come through every week. So, and our wonderful audience, thanks a lot for joining us, and we'll keep bringing high quality content to you every week. So that's it from us this week. Thank you so much.
Yep. Thanks, everybody. I am Phil Nelson, wishing you a great day wherever you may be. Take care of yourselves out there and take care of somebody else if you can. We will see you next week, 9 a.m. sharp, same bat time, same bat channel.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.